Full. పెట్టాను అందుకే సార్. Okay, students, is my PPT visible to you? Students. Okay. So how many of you done this exercise? 2-bit ripple counter, ripple down counter, and 3-bit up counter, 3-bit down counter. How many of you done, students? Students, please respond. Have you tried at least? Anyone? Students, please respond. Can I solve this exercise? Students, are you there?
Yes, sir.
Okay. See, we have studied about the asynchronous counters last class. So I explained 2-bit states. So 0 to 3. Okay. So once you complete 0, 1, 2, 3, that comes under the one cycle. Okay. After completion of one cycle, in the case of up counter, again it initial state. Here the initial state is 0. In the case of up counter, so there are 4 states. Initial state is 0, next state is 1, 2, 3. So this is the highest state, last state. So after last state, Again, it goes back to the initial state. That means 0, 0, then it change it to 0, 1 state, again 1, 0 state, again 1, 1 state. After this 1, 1 state, again it goes back to the 0, 0 state. Clock pulse on negative edge trigger. Okay. Coming to the students, please inform me if my voice are muted or my presentation is not visible to you, because sometimes here there is a problem with the network. Okay, automatically it loses its connection. So kindly inform me. Okay, if I lost. Down counters. Okay, let us see the 3-bit up counter. Okay, see this. This is 3-bit up counter. We have seen 2-bit up counter, asynchronous. See what happens. This is negative. First of all, what is the difference between 2-bit up counter and 3-bit up counter, students? Somebody please answer. Students, are you there?
Yes, sir.
Yes, sir.
So what is the difference between 2-bit asynchronous counter and 3-bit asynchronous counter?
We take 2 inputs, sir.
Three variables.
No. See, in 2-bit asynchronous counter, we are taking T flip-flop directly. So like this. Counter. So in order to have
Sir, voice remains.
Is it okay now, students?
Yes, sir.
Yes, sir.
See, so directly, so theoretical presentation T flip-flop is available, but in practical and commercial IC packages, directly T flip-flop is not available. Only JK flip-flop is available. Instead of taking like this, same T flip-flop can be designed by using JK flip-flop. Instead of taking one input, we are taking 2 inputs. So what is the difference? So if you short these 2, that comes under T flip-flop. Is it okay now, students? Students, do you understand now?
Yes, sir.
These 2 are equal. So don't confuse. If you take T directly, that means internally J and K are shorted. So most of the textbooks, they design T flip-flop by using JK flip-flop because there is no direct circuit available for T flip-flop. Only JK flip-flop is available. Simply by shorting J and K, you will get T flip-flop. That's why. So commercially available all ICs are JK flip-flops only. Understand, students? Students, do you understand?
Yes, sir.
1 here. Okay, then this comes under also same asynchronous 2-bit flip-flop, 2-bit asynchronous flip-flop. Okay, this is the clock. Okay, this is the clock for the next flip-flop. This is QA, this one is QB. So that's why don't confuse when you consider the JK. So you need to observe when J and K are shorted or not. That is very important. Observe here, J and K are shorted. So that's why this is T actually. Here also J and K are shorted. This is also T. See here, J and K are shorted. This is also T. So do you understand these, students? So this is nothing but T flip-flop. And one more thing, we are going to design a 3-bit asynchronous up counter or 3-bit ripple counter. 3-bit ripple counter. Ripple up counter. Okay. So this is the circuit, students, logic circuit. And because of 3-bit, we need 3 flip-flops. I already told you, if you want to design 1-bit counter, you need 1 flip-flop. If you want to design 2-bit counter, you have 4 states, you need 2 flip-flop. That means simply, so 1-bit.
Sir, your voice is not audible.
2 power n states. 2 power n states. So 3-bit counter means 2 power 3, 8 states are there. 8 different states. Okay, students, do you understand this? So suppose you want to design 4-bit counter, how many flip-flops you needed? Students.
16.
No, you want to design 4-bit counter, how many flip-flops needed?
4. 2 power 4.
I am not asking you number of states. I am asking you how many number of flip-flops are needed to design 4-bit counter.
4.
So in 4-bit counter, how many states are there? How many states in 4-bit counter? So 4-bit counter has 2 power 4 states, 16 states. 16 states. Because 2 power 4. So 4-bit counter has 16 states. So if you take 5-bit counter, you have 32 states, 2 power 5. Understand, students? So now we are going to design 3-bit counter, asynchronous counter. Why this is asynchronous counter? Clock is not applied simultaneously to all the flip-flops. So only first flip-flop, let us say this is A, B, C. So QA, QB, QC. Okay. So see here, only clock direct. This is negative edge trigger clock, students. This negative edge trigger clock directly applied to A flip-flop only, lower LSB flip-flop. Okay. Whereas the next flip-flop, B flip-flop, the clock is the output of the previous flip-flop. See, this is output. This is the clock for the next input. Similarly, the last MSB flip-flop, the clock is the output of the previous state or previous flip-flop. B. There is a latency. So in this asynchronous counters, there is a delay because every time you want to change the state means it must, the cumulative delay leads to have a glitches. So that is the one drawback. So there is a delay in this asynchronous counters. Okay, because one flip-flop, whether it is on and off depends upon the previous output. Again, C flip-flop, whether it is on and off depends upon the previous QB flip-flop. So that's why there is a delay in this asynchronous counter. So fundamentally, you have to recognize whether this given circuit is synchronous or asynchronous simply by observing the clock. If you observe clock, the clock here does not apply all the flip-flops simultaneously. So first clock applied to only one flip-flop. Again, next state, see output of the first flip-flop is connected to the clock for the next flip-flop. So this kind of structure, you just simply call it as asynchronous counters or asynchronous circuits. Okay, students? If you connect output original output to the clock for the next input, which comes under the up counter. So if you connect instead of QE, students, this is the circuit. Initially, all the flip-flop outputs are, okay, QA, QB, QC, QA, QB, QA. All these outputs are 0, 0 because clear output is 0. So in order to, to simple circuit, I just not drawn here preset and clear inputs. So you have to assume there is a clear initially. So all these are shorted together. Again, initially we applied 0 for this clear input. What happens if you apply 0 for the clear input? All the flip-flops outputs QA, QB, QC, irrespective of the input and the clock, output should be 0, 0, 0. Do you understand this, students? Because this is the initialization, first one. Because of the clear, we are going to get the all the outputs are 0, 0, 0. So this is called initialization of the outputs by using the asynchronous inputs. Okay, students? So that you need to understand. So for simple circuit, I just remove this asynchronous input. So now this state is completed. Now tell me, now you need to check for the operation of the all the flip-flop with respect to clock. So let us say this is A, first clock. See, all the outputs are 0, 0, 0. Again, inputs, all inputs are 1, 1 because 1 VCC means 1. Now tell me for next state at this time instant, what is the output of the QA? What is the output of the QB? What is the output of the QC? Students, please answer. Students, please respond.
0.
Which one is 0?
A.
A.
QA 0. How? See, what is the input here, students? 1, 1. Always 1, 1 because all the inputs are shorted. Again, connected to 1. That means permanently all the inputs are 1 only. That means out of 4 combinations, we are using only toggling operation here. Understand? Toggle operation. You know that JK flip-flop, if both inputs are 1, 1, previous state should be complemented. Do you know this, students?
Yes, sir.
So initial states are 0, 0, 0. Just observe here. QA, QB, QC all are 0 because we initialize the outputs to 0 by applying asynchronous clear input. So CLR bar is 0 initially. Then all the outputs forcefully goes to 0. Then this is changed to 1. So now clear is not active. Preset also not active. 1. So now the output depends upon the clock. A flip-flop. Now you tell me what is the output of the flip-flop A? This one. Students, inputs are 1, 1. Previous state is 0. I am asking what is next state? Students.
1.
So this 0 is changed to 1 because this is previous state. Inputs are 1, 1. If inputs are 1, 1 means this is T flip-flop action. If both are 1, 1 means, okay, toggle action. What is toggle means? Previous state should be complemented. Previous state should be, what is the previous state here, students? See, this is the previous state. That previous state is changed to 1 because both inputs are 1, 1 and the clock is active. Simply you remember clock is active means this is on always. Okay. this flip-flop is on. Let us say it is on means it perform the operation. Okay, don't confuse with respect to clock. Now, what is the output of QB next state? What is the output of QC next state? Here also inputs are 1, 1. Here also inputs are 1, 1. Now tell me what is the output of
1,
QB?
1.
How, students?
Toggle operation 1, 1, 1. Complement of.
See, toggle operation happens only when this B flip-flop is on. Now this B flip-flop is off because only 0 is applied to clock. What is the previous state of QA?
0.
QA is 0. So clock is 0 here. What is the state of the QB previous state? 0. So here this all 3 flip-flops is on only when the transition takes place from 1 to 0. That means previous state is 1, present state is 0, then only this flip-flop is on. Now you observe here, what is the QA previous state, students? 0. What is present state or next state?
1.
So 0, 1 is actually a positive edge trigger, but our clock here is negative edge trigger. Observe here, bubble with. That's why B flip-flop is off. First you have to make like this. C flip-flop also off because this QB is the clock for QC. See, now this is off means previous state. What is?
Sir, your voice is not audible.
Students, is my voice audible to you?
Yes, sir.
No? Okay, see here, QB or B flip-flop, previous state is 0, but see this is off because of the clock is 0. So previous state means what, students? What is the operation of previous state means? Previous state means we are maintaining same value. We are maintaining same value which is 0. See here, previous state is 0, present state also 0. Students, are you there?
Yes, sir.
What is the next state for the QC? This is off. Understand? So off means it maintains the previous state. So see here, flip-flop. See, first clock after resetting. So all outputs are 0, 0, 0. Okay, students? This is by default on every time because clock is directly applied at this instant. Clock is directly applied. So A flip-flop is always on. Always on means every clock it is on. Every clock it is on. So first clock, that means first negative edge trigger of the clock. This is first clock, this is second clock, this is third clock. Let us say A, B, each one is every clock. At the clock A timing, A must be on. A must be on. The previous state is 0 here. So next state is 1 because toggling operation. J is equal to 1, K is equal to 1. Okay, students, do you understand this?
Yes, sir.
And coming to the B flip-flop, the clock of the B flip-flop is the output of the A flip-flop. Let us say first flip-flop, A flip-flop, B flip-flop, C flip-flop. So this QA is the clock for QB. Now students, at this instant, only the A flip-flop changes its states from 0 to 1. That means like this. So 0 to 1 is not the clock for B flip-flop. B flip-flop is only takes the input and gives the output only when the transition is takes from 1 to 0. Remember, if it is 1 to 0, then only this is on. Understand, students? But here what happens? 0 to 1. See, 0 to 0, 0 to 1, 1 to 1. These three transitions are not valid. The only valid transition is 1 to 0. This is negative edge trigger, students. This is valid transition. Here, this QA is the clock for QB. That means whether this B flip-flop is on or off, that depends upon the transition of the QA. Okay. Here, the QA is changed from 0 to 1. That's why the B flip-flop is off. Because B flip-flop is off, again 0. This is the clock for the QC. Here 0 to 0 because this is off. Okay. Because this is off means we are maintaining previous state. Previous state is 0. Present state also 0. See here. Similarly, this 0, 0 means 0 is applied to C flip-flop. This is again off. So we are maintaining previous state 0 as it is. So do you understand this, students? This combination? Students, how we get 0, 0, 1?
Yes, sir.
So do you understand now one flip-flop operation purely depends upon the previous flip-flop response. Okay. So this is regarding first clock. Until, see here, because this is flip-flop, until next negative edge trigger. Next clock means B clock means these responses are maintained until next clock. So in between, whatever the inputs, output will not change. QA, QB, QC are not changed between this clock. Okay. Again at this B means again one more negative edge trigger 1 to 0. Here again first flip-flop is on. Previous state is 1. Okay. Previous state is 1. See here, students. This is previous state. Previous state is 1. So this must be changed to 0, students. Do you understand? Students, this one? Previous state is 1 here. Now first flip-flop is on. Okay. What about next state, students?
Off.
Off means, that means 0. Next state is complemented because always J and K are 1, 1. So now the output is 0. See here, the output is changed from 1 to 0. Okay. Now students, see here, there is a transition from 1 to 0. That means this is actually a clock transition. 1 to 0 means, students, this is a clock transition. See here, this is output QA. This is the clock for QB. So that's why now QB is on. Now B is on. B flip-flop is on. Previous state is 0. What is next state, students? Students, what is next state of B flip-flop?
1.
1. Because previous state is 0. Because the clock is active now. Now this previous state is changed to 1. Okay. Again, this 0 to 1 transition is not the clock for C flip-flop because all these flip-flops are negative edge trigger. So now this is off only, C flip-flop. Now students, previous state is 0. What is next state? Students?
0.
What is next state? 0. So no change because flip-flop is off. So do you understand these, students?
Yes, sir.
B transition. So this is changed here, no change. This one is changed here. This one is changed here. Okay. Now we are going to have the operation of third flip-flops, third time instant C. Now tell me, students. So at this C clock, okay. See here again, next clock. Previous states are 0, 1, 0. We know, we have seen these. Now at the third clock, okay, this is always on because directly clock is connected here. So previously this is 0. Now this must be changed to 1. Okay, students, do you understand this one? So because 0 to 1, here the previous state is 1. See here, previous state is 1. Because 0 to 1 is off flip-flop. No, this is not the actual clock. See here, at this 0 to 1, this is not the clock for the B flip-flop. So we are maintaining the same value, even though the J and K are 1, but this is not the clock actually. So clock should be 1 to 0, but here we are getting 0 to 1. So this is not the clock. That means this flip-flop is off. This flip-flop off means we are maintaining previous state, so that we are maintaining the same value. See here, previous state is 1, next state also 1. Okay, students. So coming to the C flip-flop, see this is 1 to 1. 1 to 1 means it is not the clock. So this is not valid, 1 to 1. So this is also off. So off means previous state is 0, next state also 0. So students, only one transition has taken place here. Only first flip-flop is on. Students, do you understand this?
Yes, sir.
Okay, so in this third clock, only first flip-flop is on, remaining two flip-flops are off. Okay, so coming to the fourth clock, so first we need to write what are the previous states. Here 0 previous state, here 1 is previous state, here 1 is previous state. See here. Okay, QA is 1, QB is 1, QC is 0. These are the previous states. Now students, at the fourth clock, okay, first flip-flop is on. That means previous state is complemented. That means previous state is 1, present state is 0. See, 1 is changed to 0 here. Now observe students, this is 1 to 0 transition. What is the status of B flip-flop, students, now?
1.
This is on because
Yes,
1 to 0. So on means what is present state or previous state? 1. That must be complemented because we are, if flip-flop is on means only we are having toggling operation. Flip-flop is off means previous state. So those are the only features available in T flip-flop. If T flip-flop T equal to 0, we are maintaining previous state. T equal to 1, toggle. Here, even though T equal to 1, clock is not active. That's why if clock is not active, you are going to have the previous state only. So now because this is 1 to 0 transition, see here, 1 to 0 transition, this QA is the clock for QB. That's why this previous state 1 is changed to 0. See here, this is changed to 0. Again students, because B flip-flop has the transition 1 to 0. Observe here. What is the status of C flip-flop now, students?
Off.
C flip-flop 1 to 0.
On.
1 to
1.
0 is on. See here,
0.
this one. Okay. So 1 to 0 means on. Now this previous state is 0. Now what is present state, students?
1.
1. Next state. So see here, 0 changed to 1. That's why. So this is the present state output. Next state outputs 1 0 0. Okay, students. See, all the three are changed in this combination. See here, all three are on. Okay, students. Coming to the fifth clock. Okay. So what is the present state? 1 0 0. So this is 1, this is 0, this is 0, students. Okay. See, 0, QC is 1. Now we are going to observe the E. So clock E, fifth clock. Okay. So in fifth clock, anyway, by default, first flip-flop is on every time because we are applying directly here. So previous state is 0. What is next state, students?
1.
1.
Next state is 1. Again, 0 to 1 means B flip-flop is off.
Off, sir.
See, out of these three combinations, B flip-flop is off means previous state is 0, next state also 0. So 0, no change. Again, 0 to 0 means the C
Off.
flip-flop is off.
Off.
C flip-flop is off.
Zero.
Then what happens? Previous state is 1, present state also 1, because this is off. Off means we are maintaining previous state. Okay. So now, students, this is the 5th clock. So coming to the 6th clock, first of all, we need to write what are the present states. So C is 1, B is 0, A is 1 now. So see here, QA is 1, QB is 0, QC is 1. This is the present state. Coming to the 6th clock, see here. So now, what is the first flip-flop is on, previous state is 1, present state is 0. Okay. Now, what is the status of B flip-flop, students? On. Present state is, previous state is 1. What is next state?
1.
1. Previous state is 0. Next state is 1. So see here. This must be changed to 0 to 1. What is C flip-flop? Because 0 to 1, this is off. We are maintaining same value 1 here. See here. Again, coming to the 7th clock. Okay. Let us write first what is the status of all the flip-flops. So QA is 0, QB is 1, QC is 1. Okay. So now here, because this is always on, we are taking this clock. Okay. Okay, students. Because this is always on, 0 to 1 transition, 0 to 1 transition. Okay.
Off.
Now 0 to 1 means this is off. We are maintaining previous state is 1, present state also 1. And this is also off. Previous state is 1, next state also 1. So no change, only one change. Again, now students, one complete cycle is completed. 0, 1, 2, 3, 4, 5, 6, 7. After that, you need to get initial state again. Let us check that one. So previous states are 1, 1, 1. If you go for H here, what happens? Now, because this is on, this must be changed to 1 to 0. Because problem. What happens? B flip-flop?
On.
B flip-flop is on. Again 1 to 0. Here again 1 to 0. Again this is on. C flip-flop is on. Again
1 to 0.
1 to 0.
So in this similar following clocks, you will get 0, 0, 1, 0, 1, 0 like that. So same cycle repeats. See, we have completed one complete cycle, 0 to 7, 8 states. Again 0 state. After that, you will get 0, 0, 1. If you want to check it, okay. So now what you understood, students, because of this asynchronous 3-bit up counter, the count should be in increasing order. Initial state is 0, 1. See here, after observing all these are the state transitions. This arrow marks all are the state transitions. State transition means that particular flip-flop is on. So if you observe here, A flip-flop is always on because clock directly applied to A flip-flop. That is the reason why this is always on. Clock, see here, this clock is directly applied to A flip-flop. That's why this is always on. Understand, students? That's why previous state is 0. Now that is 1. Again at this clock, previous state is 1. Change it to 1, 0. Again next clock, previous state is 0. Change it to 1. Again next clock, previous state is 1. Change it to 0. Like that. The first flip-flop is always on. It gives the toggling operation. 0 to 1, 1 to 0, 0 to 1, 1 to 0, 0 to 1, like that. So every time it changes state because clock is on. Coming to the, see, observe the waveform, students. B flip-flop, QB depends upon the QA. That means QB response depends upon the QA because QA here act as a clock for QB. So this is a negative digit trigger means QA is only applied as a clock like this. Whenever QA is transition takes from 1 to 0, see here, this is 1 to 0, then QB is changing its states from 0 to 1. Again here from 0 to 1 to 0. Again here from 0 to 1. Again here from 1 to 0. Because QA is the clock for the QB. Do you understand this, students?
Yes,
Students,
sir.
similarly, QB is the clock, negative digit clock for QC. See, QC is only changes its states when QB is transition from 1 to 0. Understand, students? Students, do you understand this?
Yes,
So this
sir.
is the actual operation. So now this is also called as the frequency divider circuit. Why? Because we are going to divide the clock. Suppose this is actual clock. This is, let us say F. If we observe QA waveform, which is F by 2, because here within half period, we are going to cover the one complete cycle here. That's why we are going to reduce this clock by 2 times. Okay, F by 2. Similarly, QB is F by 4. So within, see here, one complete cycle, it is going to cover 4 cycles. Here, one cycle, it is going to cover 2 cycles. See here, this is one cycle. QA one cycle is equal to the 2 cycles of the actual clock. Similarly, QB one cycle is equal to the 4 cycles of the clock. That's why, which is F by 4. Similarly, QC is F by 8. So you want, suppose how this is act as a frequency divider. You want to reduce the frequency. Suppose your initial frequency is 10 Hz, let us say. You want 5 Hz. That means simply you take the output of QA, you will get 5 Hz. Understand, students? So this is the very important application of this asynchronous counters. These asynchronous counters are also called as frequency divider circuits. Frequency divider circuits. Very important, students. Okay. So students, do you understand this? If you have any doubt, just ask me. Okay. Students, please respond.
Sir.
Yeah, tell me.
1 to 2 ఒకసారి ఎక్స్ప్లెయిన్ చేయరా?
1 to 2 means?
A to B. Transition.
Okay, which combination, ma? I mean, we have many combinations.
0, 1.
So
Zero,
this to this, 0, 0,
2, sir.
last one.
1 to 2, sir.
Okay, 1, 2. Okay.
Yes.
So how you got 2 from 1? Okay. So
Yes, sir.
see here. So what is the present state here, students? QA is 1, QB is 0, QC is 0. Is it right, students?
Yes,
See,
sir.
now we are going to talk about this. Okay. B. Okay, students. B. Sorry, A. Okay, A. So this is actually 1, 1. Okay. Here first clock. This should be on. If A is on means A is on. Previous state is 1. What is next state, students?
0.
0. So this 1 is changed to 0. Is it okay, students? This 1
Yes,
is changed to 0. Now this is the actually clock. See here, QA is directly connected to clock for the QB. So now the transition is from 1 to 0. Actually,
On.
the transition is from 1 to 0 means this one. See here, students. 1 to 0 is like this. Okay. So here, previously this is 1, now 0. Because of this 1 to 0, this is the actual clock transition. Now this B is on. Okay, students. B is on. B flip-flop is on because 1 to 0. So
Yes, sir.
1 to 0 is only the clock, negative edge trigger. This is 1 to 0. See here. This one, this one, this one. All the negative edge triggers are actual clocks. So now again 1, 1. Previous state is 0. What is next state, students?
1.
1. So you got 1 here. Because QB is on. Coming to the C flip-flop. See here. 1 to 0 to 1 means this is actually not a clock. This is not a clock time. So this is off. Off means we are going to the previous state. What is previous state? 0. You are having previous state is 0. Next state also 0. That's how you got 0, 1, 0. So 0, 0, 1 is previous state. 0, 1, 0 is next state. Again, if you want to calculate next output, again take this is present previous input, replace all this. Again, you are going to apply next clock. Okay, students?
Okay, sir.
Yes, sir.
See, this is very simple, students. You need to practice it because it has many applications, counters. Even though, so that's why in previous class, I explained you only 2-bit counter because you need to understand that. Okay, students? So next class, we are going to see down counter, okay, as well as synchronous counters. Okay, students?
Okay, sir.
Yes, sir.
If you have any doubt, just pen it, students. So don't be, silent. So it's not a problem. If you have any doubt, we will discuss. I will clarify your doubts, okay? Because these need to understand. So it is not easy to understand by your own, okay? So if you have any doubt, just whatever the doubt, you have to pen it and you just ask me, okay? I will continue next class, students.
Okay, sir.
Let me take attendance first.